Hey everyone, this is Ian from the OZO team at Nokia. I'm here to talk to you about the details of stitching and encoding with OZO Creator. First off, just to remind you, Creator is part of the OZO software suite, is a free download from ozo.nokia.com, is available with your OZO purchase, and of course runs on both a Mac or a PC. As we've discussed in previous chapters, OZO Creator is the perfect tool for taking your camera originals and performing edits, denoising, stitching, and encoding for delivery to your various third-party tools and distribution platforms. We've gone over edits in previous chapters, so this one is going to be about the stitching and encoding process. If you're new to stitching, you're going to want to check out our Shooting for Stitching document, which can be found in the resource library section of ozo.nokia.com. So let's get started. Here you can see I've loaded some camera original footage by importing the raw file from my desktop. I'm already looking at my footage in spherical or equirectangular mode and have my stitch seams turned on. Immediately, I recognize a couple of problems. First, I have a stool that is right in the middle of a seam line. Fortunately, the stool doesn't move, so I'm not too worried about it right now. What I am worried about is the hero performance of my actor, which is right in the middle of a seam line. As a general practice, you want to avoid having seam lines over people, things that are moving, and things that are the primary interest in the scene. In this instance, all three challenges present themselves. So what do? With OZO Creator, I can move the seam line by simply dragging it within the frame. In turn, I can also narrow the blend width of this seam. What you want to be aware of is that any blend width narrower than a 20-degree field of view could introduce geometric distortion as a result of the stitching algorithm. With this in mind, I'm going to move my seam line over as far as possible, and then I'm going to try and widen that seam as close to 20 degrees as I can get without overlapping my actor. Next, I'm going to adjust the seam line for my stool. Finally, let's take a look at the back seam convergence. As a reminder, the OZO camera allows for cable-free filming and a variety of mounting options by placing the media module and power unit in the back of the camera, where the back seam of the image is captured in 2D. And the back seam convergence slider is where OZO Creator complements OZO Camera by allowing you to set a depth point at which you want to set your convergence. This is important because you want to make sure that your convergence point matches a desired point of interest in the scene. For example, if there had been an actor or something in close proximity to the camera, then you would set your convergence point to that depth. But in this case, there is no actor, and so we're going to look around the scene and find out where we do want to set our convergence point. You can see here that the tile of the shower is misaligned here at the floor. So I can easily set my backseam convergence to fix this, and done. So those are some of the stitching tools and considerations available to you within Creator. Now let's talk about some exporting and encoding options. As you can see, you have the option of exporting fisheye DPXs, EXRs, DNGs, and high bitrate MP4s. You also have the ability to export stitched DPX and EXR sequences. Lastly, you have stitched MP4 and MP4 VR for sending to your distribution platform. A new feature in Creator 1.4.0 is the option of sending open EXR with depth maps to further enhance your visual effects flexibility. And lastly, processed audio WAV files and OZO audio interchange files for specific audio-related pipelines. As you've probably guessed, the export option that you choose is highly dependent on the complexity of your project and the number of third-party tools and processes that you're integrating with. For example, if you have a very extensive visual effects-based project, then you may be sending your files out to a third party for color grading or denoising. Those files would then continue on to get stitched either by Creator or another third-party tool before being integrated with VFX and titles. When you're finally done with that pipeline, you would then bring the stitched files back into Creator or another encoding tool to generate your final output master, which you could then use for distribution. Let's go over the details and nuances of the 360 editorial move file. I'm going to leave these at default and export these to a directory that I've already set on my desktop. Send them to the queue, open the queue, and start my render. This is a simple format that can be used in editorial applications or to quickly see what you've shot. This is not a stitched file, but actually just takes the image that was captured by the outermost left and right camera sensors on the OZO camera, performs a fisheye to equirectangular transformation, and places them side by side together. Now let's check the settings if you want to utilize Jaunt Cloud for stitching. You're going to want to choose fisheye high bitrate MP4s. This is an optimized format for Jaunt Cloud or other platforms that use MP4s in the fisheye format. I'm going to send this to the Jaunt Cloud directory that I've already created on my desktop. I have that window open on the side here so you can see what happens when I export. I'm going to hit Queue, open my queue, and start. As you can see, Creator generated a file based on my base name that I specified, and then output 8 separate MP4 files corresponding to the individual sensors on the OZO camera. It also adds a text file which you're going to upload to Jaunt's Asset Manager, and you can then manage your stitching process on that platform. Now let's talk about the export settings for sending something to Gear VR. I've already created a Gear VR folder on my desktop, and I'm going to choose Stitched MP4, which is going to bring up a subset of menu options. We have 2 stitching quality options. For our purposes and for quick review, normal is fine. If you're sending your final output, you're going to want to choose high or slow render, which is optimized for the best quality settings. I'm going to leave my default set to high and my profile to OZO Player Mobile, and in turn, for the purposes of this demo, leave all of the other settings set to the default. I'm going to send this to my queue. I'm going to open my queue and click render. Obviously, your stitching times are going to be dependent on the complexity of what you've shot and the performance of your individual system. You can check for the latest software updates and hardware requirements at ozo.nokia.com to make sure you're getting the best stitching speeds. Now let's take a look at actually loading the file onto Samsung Gear VR. Note that OZO has appropriately named the file with an _TB to note top bottom. This is an important file naming requirement for the Oculus player. If this is the first time you've loaded something onto your Galaxy device, you're going to need to put a 360 video folder within Oculus folder. To do that, it's as simple as typing 360 video, placing the file inside that folder, and dragging the contents to the Oculus folder within your asset transfer utility. From here, you can pop it into your Gear VR, go to your library, and view your content in 360. So those are a few of the stitching and exporting features of OZO Creator. Be sure to check out the other videos in the series that highlight the features of the OZO VR solution, and join us in the community forums at support.ozo.nokia.com. Thanks for watching.